Today we're gonna start a new topic, and the topic's gonna be sequences and series. And first thing I want to do is I just want to do an introduction to sequences. So, first thing we're gonna do is we're gonna just review something that we've already done before. For example, when you're doing sequences and series at school, you might have seen this sequence here. You might have had a problem like find the next 3 terms or something where you'd, figure out the pattern and just write down the next terms, or to find out the nth term. The nth term would be three n minus 1, because n's the term and that's the 3 times table. You say 3 times 1, then 3 times 2, then 3 times 3. But you can see each of these is 1 below the 3 times table, so then you have to subtract 1 from that. And the second one's actually a quadratic type, and you would actually find out that the nth term for that one would be n squared minus n. Because notice that the square numbers here are that's 2 squared, and if we subtract 2 that gives us a 2, and if we subtract 3 there that gives us a 3, 4 there that gives us a 12. So that is the right rule, so you should be able to see that pretty clearly that rule will work. Now, this first one here is called an arithmetic sequence or series, and we'll be doing that in this unit C1. This second one here is later on in the course you'll see is called a geometric, and we won't actually be studying them really any further in this unit. We'll see more of that in C2. But the problem is this isn't really very good, so we're going to introduce a new notation here. And we're going to have the term be u, and then a little n down here. That's going to be the new notation that we're going to use, just so you can write it more as a formula. So you could have a formula like, let's just put up something basic here. That would work. That's the formula. It means whatever term you want to find, the term's n, so you substitute that in and it would find you the term. That's basically what this means. So let's do a few examples here. So I'll find the first 3 terms of these. So what we'll do here is, the first one would substitute 1 into here. That would give 3 times 1 plus 2, that would be 3 plus 2, which is 5. So the first term would be 5. Second term will basically do the same thing. The second term's a 2. So we'll do 3 times 2, which is 6. And another 2, which is 8. And Then the third term would be 3 times 3 plus the 2, which is 11. And strangely enough, you can see, even though this is a different rule here, it copies that pattern up here. But you've seen it works, and this one also does satisfy this on here. If you start where the sequence actually starts, but if you want to start at 1, it might not work. Now, this next one's basically the same sort of thing. Would put 1 in here, it would be 1, 1, minus 1, which is basically 1 times 0, which would give us 0. And next, if we substitute 2 in here, that would give us 2 times 2 minus 1, which would be 2 times 1, which would give us 2. Now if we substitute 3 in, then this would be 3 times 3 minus 1, which would be 3 times 2, which would be 6. And notice that if you expand these brackets here, you actually get n squared minus n, which is the same nth term as we've got up here. So it'll produce the exact same sequence. Next one here is going to be 2 to the power of n. Well, first one's going to be 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. 2 to the power of 1 is 2, 2 squared, which you know is 4, and 2 to the 3 is 8. So the sequence goes 2, 4, 8, and so on. So this is basically how we find terms using these new rules with this new notation. It's basically the same sort of thing. I'm just changing it around a bit. Now something a bit more complicated. I want to find un minus 2. Now remember, this bit down the bottom here is the term. So what that means is everywhere where we see n, we substitute this number here. So what we're going to do is we're going to replace this n with n minus 2. And this won't come out to be a number, so let's just simplify this one. We'll expand the brackets, we'll get 5n minus 10 plus 3, which is 5n minus 7. So that would be the answer to that one. You can expect a number because the term here isn't a number. So we don't know what number n is. It's just what you should already know from algebra. And basically, if we started this sequence from a different number, maybe the rule would change. But in a way, this one here was kind of the same. We've seen that, which you could experiment with and see why that is, but I'm not going to really explain it because we could see